All right. In this video, we're going to talk about sigma notation. So sigma notation is basically a summation notation. So it allows us to write sums in a very compact way. So summation notation, the symbol we're going to use is called sigma, and it looks like that. So this is the Greek uppercase sigma. Not that that really matters, but that's why it's called sigma notation, is because we use the Greek uppercase sigma. And so let's talk about some of the parts of this notation we're going to use. So we have the sigma, and then we're going to have, let's use the numbers from the previous example, the word problem that we did. So I'm going to have, so I'm just going to set it up and then I'm going to talk about the pieces. Okay. So down here, you have your lower limit. So this is the lower limit. So we started at 1. So remember in the last video, it was 1 week to 50 weeks. So it was the first 50 weeks. So we're starting at week 1. So that's the lower limit. And we're going up to week 50. So that's the upper limit. And then this, hopefully you remember, this is the explicit formula that we found. So this is going to be the explicit formula for your sequence. And then the number of, in this case, weeks, but the term number that you're going from. So this is from 1 to 50. So we read this, the sum from n equals 1 to 50 of 2n plus 8 is how you would read that. All right, so basically what this is saying is it's saying, okay, start at 1, plug in 1. So 2 times 1 is 2 plus 8 is 10. Saying plug in 1, find that, then add. So this is a sum, right? So we're going to be adding each time. Then go to the next number. So summation notation is you're starting here and then you increase the number each time. So then you're at 2. So you'd plug 2 in here and you would get 12. And then you would plug 3 in. And so that's 14. And then you plug in 4 and that's 16. And you keep going until you are plugging in 50. And we know from the last video that if I plug in 50, I'm going to get 108, right? And then I would figure out what that sum is, which we already know what it is because we did that in the last video. But that's how summation notation works. So this is the number that you're starting in, and then you plug in each subsequent number until you get to that number, okay? The number of terms you're going to have, so the number of terms is going to be the upper limit minus the lower limit. Sorry, I'm running out of room. So upper minus lower plus 1. Upper minus lower plus 1. So in this case, right, if I did 50 minus 1 is 49 plus 1 is back to 50. I have 50 terms. That seems a little redundant if you're starting at 1. Like obviously if you're starting at 1, then the number of terms is just what's on top. But you don't have to start at 1. You could have a sum that goes from n equals 15 to 23. So then, right, I don't have 23 terms because I started at term 15. So I could subtract and then add 1, and that will give me my number of terms. So this is only really important when this is not 1. But when this is not 1, then this is helpful. It's helpful to know how many terms you expect to have. All right. So that's sigma notation. And so let's do some examples using this. So let me switch back to my mouse. And I'm gonna erase. But let's use our sigma notation. So this first one is just a simple, this is kind of as simple as it gets. Because we just have the sum from k equals 1 to 5 of k. So basically I'm just plugging this into k each time. So I start at 1, so I have 1 plus 2 plus 3 plus 4 plus 5. Right, because I'm not doing anything to it, it's just k. So I'm just adding those numbers. And that is how we would rewrite this as a series. So expanding our summation notation. So I'm expanding, if I say I want to expand this, right? That's what I'm looking for. All right, so let's look at number 4 here. So in this case, we're still going from k equals 1 to 5. But now we have a little bit more of a formula to plug it into. So I'm going to plug in 1. So I have 5 times 1. So it's 5 plus 3 is 8. And now I'm going to plug in 2. So we just go to the next one, right? So I'm just going to plug in 2. So I have 5 times 4 is 20 plus 3 is 23. And now I'm going to plug in 3. So I plugged in 1, plug in 2. Now I'm going to plug in 3. So I have 9 times 5 is 45 plus 3 is 48. And now I'm going to plug in 4. And so I have 16 times 5 is 80 plus 3 is 83. And now I'm going to plug in 5. So 5 times 5 is 25, times 5 is 125, plus 3 is 128. And then I stop because it told me to go to 5. So now that I've got 5, now I stop. So you always just go to the number that's on top. So I'm not going to plug in 6, right? Because this only says to go to 5. All right. Let's do this one. So this one actually starts at 0. So this says a equals 0 to 4. So we're still going to have 5 terms. Notice that. We're still going to have 5 terms. We're going to have 0, 1, 2, 3, 4. But now we're starting at 0 and we're going to 4. So notice our formula from earlier for the number of terms was upper minus lower plus 1. So 4 minus 0 is 4 plus 1 is 5. So that worked. We're expecting 5 terms. Okay. So we're plugging in 0. So the first term goes away and we just end up with 3. And then we plug in 1. So 4 plus 3 is 7. And then we plug in 2. So we have 4 times 4 is 16. Plus 3 is 19. And then we're going to plug in 3. So 0, 1, 2, 3. So 9 times 4 plus 3 is going to be 39. And then our last one, we're plugging in 4. So we get 16 times 4 plus 3 is 66. 7. So then we stop. Okay? Got to 4, we stop. All right. Last one we're going to do in this video, we have the summation from m equals 4 to 8. So we're starting at 4 and we're going to 8. And again, we expect to have 5 terms, right? 8 minus 4 is 4 plus 1 is 5. So we're going to have 5 terms again, but we're going to start from 4 and we're going to go to 8 this time. So we're just doing 100 minus m. So we start at 4. So 100 minus 4 is 96. And then move up to 5. So 100 minus 5 is 95. 100 minus 6 is 94. 100 minus 7 is 93. And 100 minus 8 is 92. So we're done because we got to 8. So that's all we need. Yeah, so that's summation notation. I hope that helps, and I will see you in the next video.